Hello there, and welcome to the Sleepy Science Channel. Tonight, we are drifting into the remarkable world of frogs, creatures that live at the meeting place of land, water, forests, and deserts. Frogs have been watching the world change for an unimaginably long time. We often overlook them as simple pond creatures, yet they are one of the most successful creatures to have ever existed. They have adapted, transformed, and survived in almost every environment on Earth. This is a world filled with starlit skies and gentle choruses in the night, their hidden lives unfolding beneath leaves, ponds, and moonlit surfaces. Frogs are the remarkable storytellers of evolution, messengers of environmental change, and the quiet engineers of the ecosystems they inhabit. The more you listen to their story, the more surprising and layered it becomes. As we move through this journey, you may begin to notice how much complexity can exist in something so small, and how much wonder there can be in the natural world. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, allow your shoulders to soften. Let your breathing slow, and allow the day to fade away as your mind unwinds into this fascinating world. Let's begin. Frogs breathe through lungs, skin, and even the lining of their mouths. Take a slow breath and imagine having more than one way to do it. Many frogs can pull oxygen from air with lungs, yet they can also exchange gases straight through moist skin. That means a resting frog can stay still for long stretches, while its body quietly trades oxygen and carbon dioxide with the world around it. Some species can even use the moist tissues inside the mouth to help with that exchange, which is handy when they are keeping their head above water or staying hidden. This flexibility is one reason frogs can live in places where oxygen changes from moment to moment. It also explains why clean, damp habitats matter so much. Their breathing is not sealed behind fur or feathers. It is right on the surface, in constant conversation with the environment. Some frogs can freeze solid in winter, then thaw and hop away. In the deep cold, some frogs do not flee or burrow far enough. Instead, they endure the unthinkable. As temperatures drop, ice can form in their bodies, and the frog becomes motionless. The heart stops beating. Breathing pauses. It can look like life has ended. Yet inside, chemistry is at work. Certain frogs flood their tissues with natural compounds that help protect cells from damage. So ice forms in safer places, and vital structures avoid bursting. When spring warmth returns, the frog slowly restarts. The heart begins again. Muscles wake up. Within hours, it may move as if nothing happened. This survival trick is not a party stunt. It is an answer to seasons that would otherwise erase a small animal. It is also a reminder that life can survive by bending the rules we assume are fixed. The smallest frogs can be smaller than a fingernail on your hand. In a damp patch of forest leaf litter, the world can shrink to a scale most people never notice. Some of the tiniest frog species are so small that a single raindrop can feel like a heavy weather event. At that size, survival becomes a game of hiding in plain sight. Their meals are pinhead insects and microscopic invertebrates. Their homes are the thin, humid spaces under leaves, inside moss, and in soil that stays moist. Being tiny also changes how sound and movement work. A short hop can still be a risky journey, and a soft call can still matter in the dark. These mini frogs remind us that rainforests are not only about towering trees. They are also about miniature lives, running on fast heartbeats and narrow margins, in a universe measured in centimeters. Frogs existed before dinosaurs, with roots deep in ancient amphibians. Long before towering dinosaurs ruled the land, early relatives of frogs were already exploring the world. Fossils show that the frog body plan has deep time behind it. A wide head, powerful hind legs, a shape built for quick bursts and sudden escapes. Over millions of years, that basic design proved so effective that it persisted while continents shifted and climates transformed. When dinosaurs appeared, frogs were not newcomers. They were already part of the landscape, adapting to wetlands, forests, and shifting shorelines. Thinking about that timeline can feel dizzying. A creature small enough to fit in your palm carries a history that reaches back through mass extinctions and ancient eras of Earth. Modern frogs are not primitive leftovers. They are survivors with long-tested solutions. Each spring call and each quiet pond ripple is connected to a lineage older than many of the landmarks we imagine as timeless. Many frogs drink water through skin patches on their belly and thighs. They have specialized areas of skin that can take in water directly, often on the underside of the body and along the thighs. When a frog sits in damp soil or shallow water, it can pull moisture into its body without lifting its head. This matters because frogs can lose water quickly through their permeable skin. In dry air, dehydration can arrive faster than you might expect. Absorbing water through the body surface becomes a simple, steady solution. It also changes how frogs choose their resting spots. A patch of wet leaf litter or a muddy edge can be the difference between comfort and crisis. This is one reason frogs are so closely tied to healthy wetlands. Water is not only where they live, it is part of how they function, taken in through contact rather than through a mouthful. Some frogs carry tadpoles on their backs to savor water. In a rainforest, water can be everywhere and still be hard to find in the right form. Some frogs solve this by acting as tiny transport pilots. After the eggs hatch, an adult can let tadpoles cling to its back and climb or hop to safer pools. The destination might be a small pocket of water held in a plant, or a puddle that is less crowded with hungry hunters. This is not a random ride. It is a deliberate move toward better odds. Along the way, the tadpoles stay moist and protected, and they avoid long swims through dangerous channels. For the parent, it is extra effort and extra exposure. For the young, it can be the difference between disappearing in a day and growing strong enough to transform. This behavior turns the forest into a map of nurseries and the frog into a careful guide, choosing the best places for the next generation. Frogs absorb chemicals easily, making them sensitive indicators of pollution. A frog's skin is not a sealed jacket. It is a working surface that takes in water and exchanges gases, which also means it can take in dissolved chemicals from the places it lives. That makes frogs unusually sensitive to what is happening in a wetland, a ditch, or a stream edge. When pollutants enter the water, frogs may show the effects earlier than many other animals, because exposure happens through contact as well as through food. Changes can appear in development, in behavior, and in survival, sometimes before humans notice anything wrong. In that way, frogs act like early warning signals for the health of the habitat. When frogs are thriving, it often suggests the water is supporting life in a balanced way. When frogs struggle, it can be a clue to look closer. They are not only residents of wetlands, they are living reports written in skin and biology. The largest frogs can be longer than a human forearm. There are places where a frog is not a small background creature. It is a heavyweight presence. The world's largest frogs can grow so big, but their bodies feel more like a strong animal than a delicate amphibian. When one jumps, the landing has weight. When one sits still, it can look like a smooth stone that breathes. Size changes everything. A large frog can tackle larger prey, and it has fewer predators that can swallow it whole. It can also claim prime spots along river edges where food arrives on the current. In some regions, people have long told stories about these giants because they are hard to forget once you have seen one. They show how far the frog blueprint can stretch, from tiny leaf litter sprinters to powerful riverbank athletes, all sharing the same basic idea of life. A frog's tongue flips out fast and sticks using clever saliva physics. A frog does not reach for food the way we do. It launches. The tongue can whip outward with remarkable speed, and the landing is only half the trick. The real marvel is the stick. Frog saliva can behave like a non-Newtonian fluid, which means it changes its flow depending on force. At impact, it can spread and grip. Then, during the pullback, it can shift again to keep hold of prey. The tongue itself is also built for this job. It can be soft enough to wrap slightly around an insect, increasing contact. The result is a fast, reliable capture method that works in dim light and dense vegetation. It also reveals how physics shows up in everyday life. A frog does not need claws or sharp teeth to catch a meal. It uses timing, elasticity, and a microscopic layer of sticky fluid, all coordinated in a blink. Some frogs can change color to match temperature, light, or mood. A frog can look like it is wearing a new coat without ever moving. Color change in many species comes from special skin cells that can expand or contract, shifting how pigments and light-reflecting layers appear. In cooler conditions, some frogs darken, which can help absorb warmth. In bright surroundings, others may lighten, which can reduce heat gain and also help them blend in. Social moments can play a role too. During breeding season, colors can intensify as signals to rivals or potential mates. This is not the instant dramatic trick of a movie monster. It is a living adjustment, tuned to the frog's needs and surroundings. It also means that one frog might look different from morning to night, or from shade to sun, without changing species or identity. The skin becomes a responsive surface, tracking the world like a quiet moog ring. A frog's eyes help push food down while it swallows. If you watch a frog eat, you might notice a curious movement. The eyes seem to sync or blink in a slow, determined way. This is not just expression. Many frogs use the motion of their eyeballs to help move food from the mouth toward the throat. It is a clever solution for an animal that often swallows prey whole and does not chew. The eyes sit in bony sockets that connect to the roof of the mouth. When the frog pulls the eyes downward, it adds pressure inside the head, helping guide a struggling insect or wriggling worm deeper into place. It is like having built-in plungers that work from above. Once you know this, a frog's face becomes even more fascinating. What looks like a simple blink can be part of the swallowing machine, using anatomy in a way that feels surprising and strangely elegant. Many frogs shed their skin, then eat it for nutrients. Frog skin is not a passive covering. It is active, living tissue that has to stay healthy and functional. Over time, the outer layer wears out and must be replaced. When shedding happens, a frog can wriggle and pull the old layer forward, often peeling it off in one piece like a thin suit. Then comes the part that surprises people. Many frogs eat the shed skin. It is not waste to them. It is a quick meal that returns proteins and minerals back into the body. It also reduces traces that might attract parasites or predators. This habit shows how carefully frogs manage resources. In a world where food can be unpredictable, recycling matters. It also highlights how much a frog depends on its skin as a working organ, not just a boundary. Shedding is maintenance, and eating the result is efficiency, folded into a small nightly ritual. Larger frogs can eat small reptiles, rodents, or even other frogs. Size changes the menu. a large frog is not limited to mosquitoes and flies. In the right conditions, it can take prey that surprises most people, such as small lizards, young snakes, tiny rodents, and sometimes smaller frogs. This does not mean a frog is constantly hunting big animals. It means it can take advantage of opportunities that appear near water and along banks. A struggling creature at the edge of a pond can become a sudden meal. This rule can make large frogs important regulators of shoreline life, especially in places where many young animals gather to drink. It also makes them competitors with other predators, including birds and snakes that hunt the same edges. The idea can feel shocking because frogs look harmless. Yet for smaller animals, a big frog can be a silent trap with a wide mouth and fast reflexes, waiting for one careless step. Certain frogs have teeth like bumps that grip slippery prey. Frogs are not famous for teeth, yet some have small tooth-like structures that work like gripping tools. These are not the slicing teeth of a wolf. They are more like tiny bumps or ridges that help hold prey that would otherwise wriggle free. Slippery meals are common in wet habitats, and a frog that catches a slick insect or a small aquatic creature needs a way to keep it from sliding out during the struggle. Grip matters because many frogs swallow quickly, and they do not use chewing to secure food. A small improvement in hold can mean the difference between dinner and escape. This also shows how evolution often favors subtle changes that do a practical job. A frog does not need a mouthful of daggers to succeed. It needs just enough traction to turn a fast grab into a secure capture. Sometimes survival is decided by tiny textures. Most frogs cannot chew, so they swallow prey whole. A frog's meal is often a single gulp. Without the ability to chew the way we do, many frogs rely on speed and timing. They capture prey, then swallow it whole, often while the prey is still moving. That can sound simple, yet it demands a body built for quick handling. The jaw and throat must coordinate, and the swallow must happen before the prey escapes. This feeding style also shapes what frogs can eat. Prey must fit the mouth, and it must go down in one piece. That is why many frogs choose insects and other small animals that can be managed in a single motion. It also makes the moment of capture feel intense. There is no second chance to reposition with chewing. The whole decision happens at once. In that way, a frog's feeding is like a fast gamble with high stakes, played out in a blink on a damp stage. A frog's life begins as a tadpole with gills and a tail. A frog begins as a small, soft beginning in water, then becomes something entirely different. The early stage is built for swimming and feeding in a watery world. Gills do the work of pulling oxygen from water, and a tail becomes the main engine. Over time, the body reshapes itself in a transformation that looks like science fiction, yet it happens in ponds and ditches every year. Legs appear. The head changes. The diet shifts. The way it moves shifts too. It is not just growth. It is a complete redesign, from a form suited to water into a form that can explore the edge between water and land. That journey is one reason frogs have captured human attention for centuries. They are living proof that nature can rewrite a body without losing the thread of identity. Poison dart frogs get their toxins from diet, not from magic skin. Those bright colors are not decoration. In many poison dart frogs, they are a warming sign that says, "Do not touch." What makes this even more surprising is where the danger begins. The toxins are not made from nothing. In the wild, these frogs build their chemical defenses by eating certain tiny prey, often specific ants and mites that carry potent compounds. The frog stores and modifies those chemicals, turning meals into protection. This link between diet and defense is so strong that captive frogs raised on ordinary food can lose much of their toxicity over time. It is a vivid example of ecology working like a chain. What a frog eats shapes what the frog becomes. The colors, the risks, and the survival strategy are all tied to the forest floor. Change the menu, and the whole story changes with it. Frogs hear with eardrums, but also through vibrations in their bodies. Sound is not only something frogs hear, it is something they feel. Many frogs have visible eardrums on the sides of the head, and those membranes transmit vibrations to the inner ear. Yet frogs can also sense vibrations that travel through the ground, through water, and even through their own bodies. This matters when they are sitting on a bank or floating with only part of the head above the surface. Low rumbles and subtle tremors can carry information about approaching footsteps, splashing predators, or nearby calls. Some frogs are tuned to very specific frequencies, which helps them pick out their own species in a crowded nighttime chorus. It is like hearing your name in a noisy room. Their sensory world is layered. Airborne sound, waterborne vibration, and ground tremors can all become meaningful signals. When a frog pauses and seems still, it may be listening with far more than ears alone. One tiny frog can fill a whole night with sound using an air sac. If you have ever heard a frog at night and wondered how something so small can sound so bold, the answer is clever anatomy. Many male frogs use a vocal sac that inflates like a balloon. As air moves back and forth, the sac acts as a resonator, shaping and amplifying the call without the frog needing to waste extra energy on constant new breaths. The sound can travel across water, through reeds, and into windows that are still open to the evening air. In some places, a single caller can seem like a crowd because echoes bounce off surfaces and overlap with other noises. The call is not just noise. It is a message with purpose, aimed at being noticed. The sac is part instrument and part advertisement board. It turns a small body into a nighttime broadcast station, sending information across surprising distances until the dark finally fades. Some frogs live high in mountains where nights freeze year-round. High in the mountains, cold is not a season. It is a daily reality. Some frogs survive in places where thin air and sharp temperature swings would overwhelm most amphibians. In those habitats, daylight can bring brief warmth, then darkness can snap the world back toward ice. Mountain frogs often time their activity carefully. They may feed and move during short windows, then shelter in crevices, under stones, or in insulated mud. Their bodies must cope with slow chemistry in the cold, and their breeding must fit into narrow opportunities when water is available and not locked away as ice. Living up there also means strong sunlight and fast weather changes. It is an extreme stage for a creature many people associate with warm ponds. These frogs prove that amphibian life can climb into thin, harsh places and still find a way to endure. Other frogs thrive in deserts by waiting underground for sudden rains. A desert can look empty, yet the ground can be holding a secret heartbeat. Some frogs survive long, dry stretches by disappearing beneath the surface, sealed away in cool soil where moisture lasts longer. They can remain inactive for months, sometimes for years, conserving energy as if time itself has slowed. Then rain arrives. The desert changes in hours. Shallow pools form, insects rise, and the hidden frogs wake and rush upward. In some places, their breeding happens so quickly, it feels like a natural emergency drill. Calling, mating, and egg-laying can unfold in a short burst before water vanishes again. For a frog, this is not a gamble. It is a strategy polished by harsh landscapes. These desert specialists show that survival is not always about constant movement. Sometimes it is about patience, timing, and the ability to spring into action when the world briefly offers water. Some species skip the tadpole stage and hatch as tiny froglets. Not every frog begins life as a swimming tadpole. Some species take a different route, building the whole frog body inside the egg. Instead of hatching into open water, a tiny froglet emerges, already shaped for land. This strategy can be useful in places where streams are dangerous, ponds dry out, or predators fill the water. It is also a quieter beginning. A clutch hidden in damp soil or tucked under leaves can develop out of sight, protected by the humidity of the forest floor. Inside each egg, tissues reorganize and limbs form in a sheltered world. When the shell finally gives way, the froglet steps into life ready to hop and hunt small prey. It is an example of how frogs tailor their life stories to their surroundings. They are not locked into one script. Evolution has written multiple beginnings for the same kind of animal. Certain frogs brood their eggs in their mouths for weeks. There are frogs that treat parenthood like a full-time mission. In some species, the adult takes eggs into the mouth after they are laid, keeping them safe through a vulnerable stage. Imagine the restraint that requires. Feeding becomes difficult, and every movement must avoid harming the developing young. Yet the payoff is enormous. Eggs carried this way are sheltered from drying out, from sudden temperature swings, and from many predators that patrol shallow water. As days pass, the young continue developing in a warm, protected space. When the time is right, the parent releases them, and the next stage of life begins. This kind of care also changes how we think about frogs. They are often seen as creatures that scatter eggs and leave. Mouth brooding flips that idea. It shows attention, risk, and a surprising tenderness, all wrapped into a strategy for survival. A few frogs build foam nests that protect eggs from drying. Some frogs make nurseries out of bubbles. During breeding, a pair can whip mucus and air into a thick foam, creating a floating or ground-level nest that looks like froth from a tiny storm. Inside that foam, eggs stay moist, even when the air is dry or the water level shifts. The foam can also cushion the eggs from heat and reduce the reach of some small predators. Over time, the structure slowly breaks down, and the hatchlings slip into water below, or into a safer wet space nearby. It is an engineering solution built from the body itself, using simple materials to solve a big problem. This kind of nest shows how inventive frogs can be. They do not need sticks or leaves to build protection. They turn air and mucus into a temporary shelter, timed perfectly for a fragile stage of life. Glass frogs have see-through bellies that reveal their organs. In certain cloud forests of Central and South America, a small green frog can look almost ordinary from above. Then it shifts, and the underside tells a different story. The belly skin can be so clear that you can glimpse a beating heart, looping intestines, and the outline of a liver. This is not a trick for humans. It is camouflage for life on leaves. When the predator looks up from below, the frog's outline can blur into the leaf's brightness and shadow. Some glass frogs even sleep belly down on leaves over streams, as if the leaf itself is the only blanket they need. Scientists have found that at least some species can tuck away red blood cells in the liver while resting, which can make them appear even more transparent. It is nature turning a body into a living window. Tree frogs cling with toe pads that use moisture and micro-ridges. A tree frog can climb a smooth leaf, a slick branch, and sometimes a window, and it does not need claws to do it. The secret lives in the toe pads. Under a microscope, those pads are not flat. They are covered in tiny structures that increase contact, and help control a thin film of moisture. That moisture becomes part of the grip, creating adhesion that works even on surfaces that look impossibly smooth. The frog adjusts pressure and angle with each step, testing and retesting its hold like a careful climber. In a wet forest canopy, this is the difference between feeding safely and falling into danger. It also opens up an entire vertical world. A pond is no longer the whole habitat. Leaves, trunks, and high branches become roads and hunting grounds. The next time you see a frog perched above eye level, remember it is using physics with every touch. Burrowing frogs have hard spades on their feet for digging. When the ground begins to dry, some frogs do not search for a new pond. They vanish. Burrowing species often have hardened structures on their hind feet that work like digging tools, sometimes called spades. With rapid kicks, the frog backs itself into soil, sinking down until it finds cooler, moister layers below. Down there, it can wait out harsh conditions that would dehydrate an exposed body. This is not just hiding. It is a lifestyle built around the underground. The frog's shape, skin, and behavior all support a rhythm of disappearing and reappearing when the surface world becomes livable again. To an observer, it can feel like the frog has teleported. One moment it is on open ground. The next, the spot is empty. In reality, it has simply taken the secret door that soil provides, using its own feet as shovels. Many frogs can jump far because their legs store springy tendon energy. A frog's jump can look like pure muscle, but a lot of the power comes from elastic storage. Tendons and stretchy tissues in the legs can load energy like a drawn bow. The frog crouches, compresses, and holds tension, then releases it in a sudden burst that launches the body forward. This allows a small animal to produce a big leap without needing endless raw strength. It is useful for escaping predators, crossing gaps, and striking toward prey, all in a single decisive move. The jump is also remarkably controlled. The frog can change angle, adjust body posture mid-flight, and land with a plan rather than a crash. In the wild, a good jump is often the difference between being seen and being gone. That is why frog legs are not just long. They are built like natural springs, designed to turn stored energy into instant distance. Some frogs walk instead of hopping, using a careful stepping gait. Hopping is famous, yet not every frog moves like a bouncing rubber ball. Some species walk, placing one foot and then the next with a steady, deliberate rhythm. This can be useful in tight spaces where a jump would overshoot a target, or on narrow branches where balance matters more than speed. Walking also helps when a frog is stalking prey at close range, because a sudden hop can warn an insect before the strike. In certain frogs, the body looks almost relaxed during this movement, with hips and shoulders shifting as if the animal is testing each step for stability. Watching it can feel oddly familiar, like seeing a tiny creature borrow a mammal's style for a moment. It is a reminder that frogs are not locked into one mode of travel. The frog body plan is flexible. Even something as iconic as the hop is optional when the environment rewards patience and control. Frog skin contains antimicrobial compounds that help fight infections. Frog skin is more than a surface. It is a chemical shield. Many species produce compounds in their skin secretions that can slow or stop the growth of microbes. This matters because frogs live in damp places where bacteria and fungi thrive. A moist body in a wet habitat is an invitation to infection, so chemical defense becomes a daily necessity. Researchers have studied these skin compounds for decades, partly because they can show new ways to think about controlling harmful microbes. In the frog's world, the goal is simple. Keep the skin healthy enough to breathe through, to absorb water, and to stay resilient against scratches and parasites. The chemistry can vary from species to species, which means a rainforest hillside may hold a library of different solutions. It is a quiet form of innovation, written into the skin of animals that most people only notice when they hear a call at night. Some frogs can regenerate damaged toes and sometimes parts of limbs. If a frog loses a toe or suffers an injury that would be permanent for many animals, the story is not always finished. Some frogs can regrow damaged toes, and in certain cases they can restore more complex structures. This ability is not unlimited, and it varies widely across species and life stages. But when it happens, it feels like nature revealing a hidden repair mode. Regeneration requires cells to coordinate, rebuild tissues, and reconnect function, all while the animal continues living in a world full of risks. For a frog, this can mean recovering climbing ability, improving swimming control, or simply restoring balance after a close escape. Scientists study regeneration because it can hint at how bodies decide what to rebuild and how far to go. In the frog's everyday life, it is a practical advantage. A narrow escape does not always have to become a lifelong handicap. Sometimes the body can rewrite what was lost. Certain frogs can slow their metabolism to survive long droughts. When water disappears, a frog's greatest danger is not hunger. It is drying out. Some species respond by entering a low energy state where metabolism drops, movement stops, and the body uses fuel at a slow, careful pace. In effect, the frog makes itself wait. Buried in soil or tucked into a protected pocket, it can ride out weeks or months that would otherwise be fatal. The body becomes a savings account, spending as little as possible until conditions improve. This strategy can be paired with a cocoon of shed skin in some species, which helps reduce water loss and adds another layer of protection. Then, when rain finally returns, the frog can revive and rejoin the surface world with startling speed. It is a survival pattern built for climates that swing between abundance and scarcity. The frog does not need constant comfort. It needs timing. It needs endurance. It needs the ability to turn down life's volume until the environment turns it back up. Tadpoles can be grazers, filter feeders, predators, or even scavengers. If you picture every tadpole as a tiny vegetarian with a wiggly tail, the pond is about to surprise you. In some species, the young spend their days scraping algae from surfaces like miniature lawnmowers. Others filter fine particles from the water, turning a cloudy soup into food. Some are built for hunting, with mouths and behavior suited to chasing smaller animals. A few will scavenge, cleaning up what the pond offers after storms or die-offs. This variety is not a fun detail. It changes how a whole pond functions. It affects water clarity, algae growth, and which insects thrive. It also means that different tadpoles can share the same water without competing in exactly the same way. A single pond can hold many feeding strategies at once, each one shaped by local conditions. Tadpoles are not one thing. They are a whole set of lifestyles. Some tadpoles form schools, which can reduce each individual's risk. In still water, being alone can be dangerous. Some tadpoles respond by gathering into tight, coordinated groups that move as one shifting shape. A predator that lunges at a school has trouble targeting a single body because the mass of tails and shadows keeps changing. In that confusion, any one tadpole has a better chance of being missed. Schooling can also help with foraging. A moving group can stir up food particles and uncover algae on surfaces, which makes feeding easier for everyone. The group can even act like an early warning system. When one tadpole bolts, the rest can copy the motion in an instant. To a human watching from above, it can look like a dark cloud, that suddenly turns and pours across the pond. It is a simple idea, yet it is powerful. Safety can come from rhythm and togetherness, even at the earliest stage of a frog's life. Many tadpoles have keratin mouthparts that scrape algae from rocks. Look closely at a tadpole clinging to a stone in a stream, and you may see a mouth built like a small tool. Many species have tough keratin-based mouthparts, sometimes arranged like tiny tooth rows. They use them to rasp algae and biofilm from rocks, wood, and plant stems. In fast water, this matters. Food does not sit still. The current keeps moving, so the tadpole has to hold on and harvest what grows on solid surfaces. This scraping life can shape the stream itself. By grazing, tadpoles can influence how much algae builds up, which affects oxygen levels and the tiny creatures that live in that slimy layer. It is easy to think of tadpoles as helpless babies. Yet here they are, working like underwater gardeners, gripping stones, resisting flow, and steadily clearing a living carpet from the stream bed. Certain tadpoles eat mosquito larvae, which can reduce local biting pressure. In warm months, mosquitoes turn still water into a nursery. Yet in some ponds, mosquito larvae are not safe. Certain tadpoles will eat them, snapping up the wriggling bodies near the surface. This does not mean frogs are a simple solution for every mosquito problem, because ecology is never that tidy. Still, it shows how young frogs can influence the insects that shape our summers. When tadpoles are abundant, they can add real predation pressure in small pools and ditches where larvae concentrate. This also changes how you can view a pond. It is not just a place where mosquitoes breed. It is a place where many species interact, compete, and hunt each other. A tadpole that eats larvae is doing more than feeding. It is shifting the balance of who thrives and who struggles. Even before becoming a frog, it can affect the experience of the animals around it, including us, one mouthful at a time. In a few species, tadpoles are cannibalistic when food is scarce. A shrinking pond can become a harsh classroom. When algae fades and competition rises, some tadpoles switch to a strategy that sounds shocking. They may attack and eat other tadpoles, sometimes even their own kind. This behavior is not cruelty. It is survival under pressure, and it can be triggered by crowding and hunger. A tadpole that gains extra protein can grow faster, which matters when water is evaporating and time is running out. In some species, individuals even develop different body forms depending on conditions, with stronger jaws suited to this risky diet. The pond becomes a place where environment shapes behavior in real time. It is also a reminder that nature does not promise comfort. Tadpoles live in worlds where resources can collapse suddenly. When that happens, some respond with a drastic shift. The same animal that once grazed peacefully can become a predator, because scarcity rewrites the rules. Tadpoles can sense chemical cues that signal predators nearby. A tadpole does not need to see a predator to know trouble is close. Many can detect chemicals in the water that hint at danger, including scents released by predators or alarm cues from injured peers. That information can change behavior fast. A tadpole may freeze, sink, or stop feeding, even if the water looks calm. Some will shift where they spend time, choosing deeper areas or thicker plant cover. This chemical awareness is like reading invisible headlines in the pond. It helps because water carries information in ways air does not. A ripple fades quickly, yet molecules can linger and drift. For a small animal with limited defenses, this early warning system can be the difference between growing up and disappearing. It also adds depth to pond life. Beneath the surface, there is a constant flow of signals. Tadpoles are listening with their skin and senses, tracking threats through chemistry rather than through sight alone. Some tadpoles grow larger tails when danger is high, improving escape. In some ponds, fear can shape the body. When tadpoles detect higher risk from predators, they can develop tails that are deeper or more muscular, which can help them sprint away with stronger bursts. This is not a choice made by thinking. It is a biological response, guided by cues in the water that signal danger. The payoff is speed, yet there is a cost. Building extra tail tissue requires energy that could have gone into overall growth or faster development. Still, in a pond full of hunters, survival comes first. The result is a living example of flexibility. The same species can produce different body shapes depending on the threats around it. It is a kind of emergency design built into development. If you could compare two tadpoles from different ponds, you might see different proportions, different swimming styles, and different odds of making it. Risk is not only a feeling. Sometimes it becomes anatomy. Metamorphosis reorganizes the gut because plant diets become insect diets. The change from tadpole to frog is not only about legs and lungs. Inside, the digestive system transforms too. A tadpole that spends its days grazing algae needs a gut suited to processing plant material, which can be bulky and slow to digest. As the animal shifts toward a diet of insects and other small prey, the gut no longer needs the same setup. During metamorphosis, tissues remodel, and the digestive tract changes form to match a new kind of meal. It is like swapping out the kitchen for a new cuisine. This internal shift helps explain why metamorphosis can be such an intense period. The body is not adding features on top of the old plan. It is rebuilding systems to suit a different lifestyle. Afterward, the young frog can hunt and digest in a way the tadpole never could. The transformation is not a costume change. It is a complete change in how the animal fuels its life. During metamorphosis, a tadpole's tail is absorbed and recycled as fuel. The disappearing tail is one of the strangest parts of a frog's transformation. It does not simply fall off. The body breaks it down and reuses the materials. Proteins and other resources stored in that tail can be redirected to support growth elsewhere, helping power the demanding changes that are happening at the same time. This recycling is efficient, and it is also necessary. Metamorphosis can reduce feeding for a period, because the mouth and gut are changing. The animal needs internal reserves to get through. The tail becomes a built-in pantry, and then it becomes raw material for the new body. If you could watch the process in slow motion, it would look like the tadpole is carefully packing up one life to build another. It is a reminder that development can be both dramatic and practical. Even in a pond, biology wastes very little. Frog development is guided by thyroid hormones acting like a body-wide switch. Behind the visible transformation is a quiet chemical conductor. Thyroid hormones help coordinate many of the changes that turn a tadpole into a frog, timing the growth of limbs, the reshaping of organs, and the shifting of tissues across the body. It is not one change at a time. It is a synchronized sequence, and hormones help keep it from becoming chaos. If hormone levels rise too early or too late, the results can be harmful because the body depends on the right order. This makes development both powerful and sensitive. It is one reason environmental conditions matter so much in a tadpole's world. Temperature, nutrition, and water quality can influence how smoothly the process unfolds. Thinking about this can make metamorphosis feel even more astonishing. A whole body responds to chemical signals, like a city changing its layout according to a planned schedule. Tiny molecules set the pace, and the animal follows, step by step, toward a new way of living. Frogs are cold-blooded, so their activity depends strongly on temperature. A frog's energy is closely tied to the warmth around it. In cool conditions, muscles work more slowly, reaction times stretch, and movement becomes cautious. In warmth, the same frog can become quick, hungry, and alert. This link shapes everything about frog life. It influences when they hunt, when they call, and even where they choose to rest during the day. A sunny rock can become a charging station. A shaded puddle can become a refuge from overheating. Temperature also shapes development, which can affect how fast young frogs reach the next stage of life. Because frogs do not generate their own steady internal heat, they must read the landscape like a map of safe zones and dangerous extremes. This makes them sensitive to changing weather patterns and to shifting seasons. It is not just comfort. It is capability. For a frog, warmth can mean speed and survival. Cold can mean stillness and vulnerability. Their bodies are tuned to the world's thermometer. A frog's heart has 3 chambers, blending blood in a unique way. Inside a frog's chest, the heart runs on a plan that is different from ours. Instead of 4 chambers, there are 3, 2 upper chambers and 1 lower chamber. This design can allow some mixing of oxygen-rich and oxygen-poor blood, yet it also supports flexible circulation that suits a creature living between water and land. A frog may need one pattern of blood flow while breathing air and another while exchanging gases through skin in water. The heart's structure helps make that shifting lifestyle possible. It is not a flawed version of a mammal heart. It is a heart built for amphibious reality. This can be especially useful during diving or resting, when the frog's breathing patterns change and the body needs to prioritize different tissues. Thinking about that heartbeat can change how you see a frog sitting still. Beneath the quiet skin is a circulation system designed for a life that does not choose one world. It uses both. Some frogs practice explosive breeding where whole ponds erupt with activity. In some places, a pond can seem empty for weeks, and then everything happens at once. After the right rain, frogs may converge in a sudden rush, turning one small stretch of water into a crowded, noisy gathering. The timing is the point. By breeding all together, they can overwhelm predators with sheer numbers, so more eggs and young slip through the danger. It also means adults do not need to stay exposed for long. They arrive, call, mate, and depart in a short window, sometimes in a single night. For anyone who stumbles across it, it can feel like nature flipped a switch. The shoreline is alive with movement, and the air vibrates with competing voices. It is a reminder that frog life is often paced by weather and by patience. When the moment arrives, they spend it fast. Frogs can lay eggs in leaf cups, tree holes, or tiny rain pools. A frog does not need a big pond to start a new life. In forests, water collects in surprising places, and frogs have learned to use them. A leaf can hold a small cup of rain. A hollow in a tree can become a miniature pond. A palm or a fallen branch can trap enough water for a clutch to begin. These tiny nurseries can offer safety because large fish and many aquatic predators cannot reach them. Yet they also demand precision. The water may warm quickly, it may evaporate, and it may hold only limited food. That is why choosing the right pocket matters, and why some species return to the same kinds of hidden containers again and again. It is a different way to imagine frog habitats. A forest is not just land with streams running through it. It is a web of little reservoirs scattered like secret rooms. Certain frogs lay eggs on land, then rain washes hatchlings to water. For some frogs, the safest beginning is not in open water. It is on land, tucked into damp places where fish and many aquatic hunters cannot reach. Eggs may be placed in moist leaf litter, on muddy banks, or on overhanging vegetation near streams. The choice sets up a clever handoff. When rain arrives, water carries the hatchlings down into pools and channels where they can continue developing. It is a strategy built around timing and around trust in the weather. Put the eggs too far from water, and the young may never reach safety. Put them too close, and flooding may sweep them away too soon. In the right spot, land becomes a cradle, and rain becomes transport. This approach shows how frogs use whole landscapes, not just ponds, to solve the problem of bringing new life into a risky world. Some species guard eggs, fanning them with legs to prevent fungus. Eggs seem still, yet they are busy, living bundles that need oxygen and stable conditions. In some frog species, a parent stays close and actively protects them. The adult may position the body over the clutch and use leg movements to circulate water or air around the eggs. This fanning can help prevent fungal growth and keep the embryos supplied with fresh oxygen. It also deters small predators that might peek at the clutch when no one is watching. The cost is real. Guarding ties the parent to one place, and it can reduce feeding and increase exposure. Still, for eggs that might otherwise fail, that attention can be the difference between a silent end and a successful hatch. It changes the story many people tell about frogs. Not every frog scatters eggs and vanishes. Some stay. Some work. Some invest in the fragile beginning, one careful movement at a time. A few frogs give live birth, with embryos developing inside the mother. Most frogs begin as eggs laid into the world, but a few species take a more intimate path. In these cases, the young develop inside the mother, and she gives birth to live offspring rather than leaving eggs behind. This approach can protect developing young from drying out, from sudden cold snaps, and from many predators that hunt eggs in shallow water. It also means the mother carries the weight of reproduction in a direct and demanding way. She must balance her own survival with the needs of the developing young through weeks or months of internal growth. For listeners, it can be a startling twist. Frogs feel familiar, yet here is a pattern more often associated with mammals. It is another reminder that amphibians are not locked into one reproductive script. They have experimented across evolution with many solutions, and live birth is one of the most dramatic. Some males build and defend nesting sites, acting like tiny territory owners. In certain frog species, a good nesting spot is valuable enough to claim. A male may choose a patch of mud, a shallow depression, or a protected edge of water and treat it like property. He calls from there, he patrols it, and he may drive away rivals that try to move in. The site can matter because it offers better oxygen, better shelter, or a safer place for eggs to develop. Sometimes the nest itself is shaped or cleared, which makes the spot more than a location. It becomes a prepared space. This turns breeding into more than singing and hoping. It becomes strategy and defense. When a female arrives, the nest can serve as proof that the male has invested effort and can hold a resource. It is a small-scale version of a familiar pattern across nature. Build something worth having, then protect it long enough for it to matter. In certain frogs, parents feed unfertilized eggs to growing tadpoles. Some frog nurseries are too small or too isolated to provide enough food, so a parent brings the food. In certain species, tadpoles are raised in tiny pools where algae and insects are scarce. To keep them growing, a parent returns and provides unfertilized eggs that the tadpoles can eat. This is not a mistake in reproduction. It is a deliberate meal plan. The parent is converting energy into a portable, safe form that can be delivered directly to the young. It also allows the tadpoles to stay in protected places that many predators cannot access. The trade-off is effort and time. The parent must revisit the nursery repeatedly, and each trip carries risk. Yet the payoff is a better chance that the young reach the stage where they can leave the nursery behind. It is care that looks almost like provisioning in birds, adapted to an amphibian world of water pockets and hidden cradles. Some frogs raise tadpoles in bromeliads, one little nursery at a time. A bromeliad can hold a small pool of water between its leaves, and some frogs turn those pools into private nurseries. Instead of trusting a big pond crowded with hungry mouths, a parent uses these plant reservoirs as scattered childcare stations. Each nursery is small, sheltered, and lifted off the ground, which can reduce the number of predators that can reach it. The parent may climb from plant to plant, checking water levels and placing young where conditions are best. The forest canopy becomes a network of tiny ponds, each one a separate world with its own temperature, oxygen, and food limits. Raising tadpoles this way takes planning, because each pool can support only so much life. That is why the approach feels so deliberate. It turns a plant into habitat, and it turns the parent into a careful manager of resources, distributing young across the living architecture of the forest. A handful of frogs use streams so fast, the eggs must cling tightly. Fast streams are beautiful, but they are not forgiving. For frogs that breed in rushing water, the current can tear eggs away in moments. That is why some stream-breeding species rely on eggs that stick firmly to rocks, or that are placed in sheltered pockets where flow is reduced. The location matters as much as the egg itself. A rock face behind a small barrier can become a calmer microhabitat, even while the main stream roars beside it. The reward for choosing swift water is often cleaner, more oxygen-rich conditions, and fewer of the predators that thrive in still ponds. Yet the risks are constant. A flood can scour the streambed. A strong surge can peel eggs away. Breeding here is a test of precision. It is not just about making eggs. It is about anchoring a future to a surface that refuses to stay still, in a world where water is always moving. Some frog eggs contain jelly layers that block harmful sunlight. Frog eggs are not just round dots in water. Their jelly coats can be complex, layered, and protective. In shallow pools and sunlit puddles, intense sunlight can damage developing embryos, so some eggs include jelly that helps filter harmful rays. This matters because many frogs breed in exposed places where shade is limited and where the water can warm quickly under open sky. The jelly can also help with moisture balance and physical cushioning, yet the light protection is a striking detail because it turns the egg into a kind of natural sunscreen package. Each embryo develops inside a small, clear world that is engineered for survival before the animal has any way to move away from danger. When you see frogs spawn, it is easy to think it is simple. Up close, it is a designed environment. The egg coat is doing work, managing light and chemistry, so development can proceed even in bright, risky water. Many frogs are ambush predators, striking in a blink when prey moves. Stillness is part of the strategy. Many frogs do not chase. They wait. A frog may sit at the edge of a pond or on a damp log, watching for the tiniest twitch. Movement is the trigger that matters most, because quick prey is often easiest to spot when it shifts. Then the strike happens fast enough to feel unreal. The body launches, the mouth opens, and the prey is gone before the scene looks changed. This hunting style saves energy, which is valuable for an animal that lives on a tight budget of warmth and moisture. It also makes frogs important in places where insects surge after rain. A quiet frog can become a nightly checkpoint, turning a stream of flying and crawling creatures into dinner. Waiting can look passive. In a frog, waiting is aim, timing, and patience made sharp. Some frogs hunt ants, termites, or beetles, shaping insect communities. In many habitats, ants and termites are like the background machinery of the world. They build, they tunnel, they harvest, and they multiply quickly. Some frogs make a living by focusing on these hard-working insects, and that choice can ripple outward. When a frog targets ants, it can influence which ant species dominate a patch of ground. When it targets termites, it can affect how quickly wood and leaf litter get processed. Beetles add another layer, because some are plant eaters and some are predators themselves. A frog that eats beetles can shift who gets to feast on leaves and who gets to hunt other insects. This is not dramatic like a lion on a savanna, yet it is powerful in a smaller world. Frogs are often overlooked as insect hunters, but their appetites can quietly reshape the busy societies under your feet. Some frogs use their hands to stuff food into their mouths. Not every frog relies only on tongue and jaw. Some will actively use their front feet to push food into their mouth, especially when prey is large, awkward, or still struggling. It can look almost like a person helping a bite along. The frog pins the prey, adjusts its grip, and nudges it into place so the swallow can succeed. This behavior is striking because it feels deliberate and almost clever, even though it is guided by instinct and experience. It also hints at the physical challenge of swallowing whole. A long insect, a spiny beetle, or a slippery creature can get stuck at the edge of the mouth. Hands become tools for solving the problem. This small detail can change how you see a frog's body. Those front feet are not only for landing and climbing. Sometimes they are part of the feeding apparatus, turning a quick grab into a finished meal. Frogs help control pests, but they also feed birds, fish, and snakes. A frog is both hunter and hunted, and that balance is part of why ecosystems stay stable. When frogs eat insects, they can reduce the numbers of crop nibblers and biting pests. Yet frogs are also a crucial food source for many animals that people do notice, including herons, kingfishers, trout, bass, garter snakes, and even mammals near wetlands. That means frog populations can influence the success of predators up and down the food chain. When frog numbers rise, more young birds may fledge, and more fish may grow quickly. When frog numbers drop, those same predators may struggle or switch prey, creating new pressure elsewhere. This double role makes frogs feel like living connectors, transferring energy from swarming insects into larger bodies that roam farther and shape bigger territories. A frog on a lily pad is not only a single creature. It is a moving packet of calories, poised to travel through the ecosystem in two directions. Frogs are key links in food webs, moving energy between land and water. Many animals stay mostly in one realm. Frogs do not. They often begin life in water, then spend adult life partly on land, and they can move back and forth with the seasons. That motion carries energy with it. A tadpole feeding in a pond turns aquatic resources into growing tissue. Later, a young frog hops onto land and becomes prey for land predators, or it eats land insects and returns to the water to breed. In that way, frogs act like shuttles between ecosystems that might otherwise be more separate. Nutrients and calories move with them. Even their waste can fertilize the places they visit. This matters in wetlands, forest edges, and streams, where boundaries are thin and everything affects everything else. Frogs are not just residents of ponds. They are couriers. They help tie a watery world to a leafy world, and they keep the exchange flowing in both directions. A pond with many frog species often supports more diverse predators too. A pond that hosts many kinds of frogs tends to offer a wider menu across seasons and sizes. Some species call and breed early, others later. Some produce small young, others produce larger young. That variety can support a larger cast of predators because different hunters specialize in different opportunities. A dragonfly nymph may target one size class. A fish may prefer another. A wading bird may arrive when adults gather at the edge. Diversity in frogs can create diversity in timing, and timing is food. This can make a pond feel more alive overall, with more interactions and more niche roles being filled. It is like a theatre with many performances scheduled, rather than one short show. It also means that protecting frog diversity can help protect the wider community, including predators that people value and notice. When you hear different calls from the same pond, you are also hearing the foundation of a more complex food web. When frogs vanish, insect outbreaks and algae shifts can follow quickly. Frogs sit in the middle of many relationships, so their absence can change the balance faster than people expect. If frogs decline, insects that were once eaten may increase, and that can affect crops, gardens, and human comfort near wetlands. In water, the loss of tadpoles can also matter, because many tadpoles graze algae or process particles. When that pressure disappears, algal growth and water clarity can shift, which can change oxygen levels and stress other species. Predators that relied on frogs may switch prey, adding new pressure on insects, fish, or small animals that were not previously targeted as heavily. The result can be a cascade that feels confusing if you only look at one species at a time. Frogs are often described as indicators of environmental health, yet they are also active participants in keeping habitats balanced. When they vanish, the ecosystem does not simply become quieter. It can become reorganized. Male frogs often sing to attract mates, and each species has a signature call. On a warm night near water, the air can feel stitched together by sound. A male frog calls because calling is how he becomes findable in darkness. Each species has its own pattern, like an audio name tag, so the right partners can locate each other even when many voices overlap. Some calls are short and repeated, others are long and rolling, and some come in sharp bursts that sound almost mechanical. The call can carry information about size and stamina, because producing it costs energy. In crowded places, a male may choose a calling spot that helps the sound travel, such as a reed, a rock edge, or a shallow pool. For the listener, it can seem like background noise. For frogs, it is navigation, courtship, and identity all at once. Some frog calls are ultrasonic, too high for human ears. Not all frog voices live in the range we can hear. Some species produce calls that reach into ultrasonic territory, which means they can sound almost silent to people standing nearby. Yet to another frog, that high pitch can be clear and urgent. Why call where humans cannot follow? One advantage is a quieter channel, because fewer animals compete at those frequencies. Another is privacy. If a predator does not hear the signal, the caller may reduce risk while still reaching a mate. High-frequency sound also behaves differently around leaves and branches, which can shape how far it travels and what direction it seems to come from. The result is a hidden soundscape layered over the one we notice. You can stand beside a stream and think the night is calm, while an invisible concert is happening above your hearing. It is a reminder that nature is not only what we perceive, it is also what we miss. Many frogs use a vocal sac as a resonator, not just a balloon. When a frog calls, the inflated throat can look like a simple bubble of air. It is more impressive than that. The vocal sac acts like a resonator, shaping the sound and boosting it, so the call carries farther with less effort. Air moves back and forth between lungs and sac, which means the frog does not need to take a fresh breath for every note. That recycling makes long calling bouts possible, even for a small body. The sac can also help aim the sound. Depending on how the frog is positioned, the call can project across water or through reeds like a speaker turned toward an audience. In some species, the SAC's size and color add a visual signal that matches the voice, which can matter at close range. It is a multi-purpose instrument built into the frog's anatomy. The next time you hear a call, imagine the throat as a tuned chamber, not just an inflatable pouch. In some species, females choose males with the most consistent rhythm of the sounds they make. A frog chorus is not random noise. It can be a contest of timing. In certain species, females show preferences for calls with steady rhythm and reliable spacing, as if the beat itself carries meaning. Consistency can hint at a male's stamina, coordination, and ability to keep calling through interruptions. It can also help a female track a single voice in a crowded sound field, because a predictable pattern is easier to follow. That choice can shape evolution over generations. Males that hold the rhythm get more chances to pass on their traits, while messy callers may be ignored even if they are close by. On nights when many males call, the difference between being chosen and being overlooked can be a subtle change in tempo. It is courtship measured in milliseconds, played out on pond edges. For humans, it might sound like simple croaking. For frogs, it can be music with rules. Rival males may wrestle, shove, or call over each other all night. A breeding pond can feel peaceful until you notice the tension beneath the sound. When many males gather, space and attention become valuable, and some will fight for both. They may push, grapple, or try to dislodge a rival from a prime calling spot. More often, the battle is acoustic. A male may call louder, call faster, or time his notes to overlap another male's signal, trying to blur a competitor's message. Some species even form small clusters where neighbors constantly adjust their calls, like a living volume war. The conflict can last for hours, because the opportunity window is short and the stakes are high. If a male loses a position near the best water, he may lose the night. If he holds it, he may attract a mate. It is a reminder that frog life is not only hiding and hopping, it is also rivalry, strategy, and endurance, performed in the dark with voices and bodies. Some frogs can throw their voices using the landscape for amplification. In certain habitats, a frog's call can seem to come from nowhere or from a direction that feels wrong. Part of that is the landscape. Water surfaces reflect sound. Dense vegetation absorbs some frequencies and bounces others. Rock walls and stream banks can create echoes that blur the true source. A frog can take advantage of this by choosing a calling position that makes the sound travel, such as a hollow log, a bank curve, or a pocket of reeds that acts like a funnel. To a listener, the call can feel larger than the animal, as if the night itself is speaking. This can confuse predators and also draw in mates from a wider area. It is not a magic trick. It is acoustics. The frog is using the environment as part of its instrument, turning pond edges and ravines into natural amplifiers. When you hear a call and cannot locate it, you are experiencing the same puzzle other animals face. Certain frogs call from underground, turning soil into a natural speaker. Some frogs perform their songs from beneath the surface, with only a small opening to the outside world. It sounds strange, yet it can be effective. Soil and burrow walls can filter the call, shaping it into a lower, booming quality that carries in a different way than an open-air voice. Calling underground can also provide safety. A frog can advertise without sitting fully exposed on the surface, which reduces the chance of being grabbed by a night hunter. In dry regions, burrows can keep moisture close, so the frog can call without drying out as quickly. The burrow becomes both shelter and stage. To a human ear, the sound can seem like it is coming from the ground itself, like a hidden engine under the dirt. This behavior shows how flexible frogs can be with communication. They do not only sing from lily pads. They can turn a tunnel into a sound booth and still reach the audience they need. A few frogs make ticking sounds without opening their mouths much. Not every frog call is a classic croak. Some species produce sharp clicks or taps that sound more like tiny stones striking than like a voice. These sounds can be made with minimal mouth movement, which can help the frog stay less visible while still communicating. In a crowded habitat, clicks can also cut through background noise because a sudden percussive sound is easy to notice. The effect can be surprising. You might expect a loud throat and an open mouth, then realize the frog seems almost still. Yet the sound continues, steady and purposeful. Clicks can be used for attracting mates, for spacing between rivals, or for announcing presence in a specific patch of habitat. They add variety to the nighttime soundscape, proving that frog communication is not one simple style repeated worldwide. It is a toolbox. Some frogs use a booming note. Others use a fast click, and both can be equally effective. Some frogs call from water, creating ripples that can reveal their location. Calling from the water can give a frog quick escape routes because a dive is only a flick away. Yet it comes with a risk that is easy to overlook. When a frog inflates a vocal sac at the surface, it can disturb the water and send out ripples. Those ripples can act like a visual beacon for predators that hunt by sight or vibration. Even in dim light, a pattern on the surface can point to the caller's exact spot. That means the frog must balance two needs: being heard and staying alive. Some will call from partial cover, nestled among plants or near edges where surface movement looks less obvious. Others may time calls in bursts, then go still, making the ripples fade before the next message. It is communication with consequences. The call is not free. It can announce more than romance. It can announce location. Yet frogs keep doing it, because the chance to be found by a mate is worth the danger. Frogs can tell direction partly by timing differences between their ears. In a dark pond edge chorus, finding a single caller can feel impossible. Frogs manage it by using subtle timing cues. A sound reaches one ear a tiny fraction of a moment before the other, and the brain can use that difference to estimate direction. The head may be small, yet the system is sensitive enough to guide turning, hopping, and approach. Direction finding also helps avoid trouble. A frog can orient away from sudden splashes or footsteps, even before the threat is visible. In dense vegetation, this skill becomes crucial, because sightlines are short and the night is crowded with movement. Some frogs also benefit from the way their ear structures connect through the head, which can enhance contrast between left and right inputs. The result is a kind of nighttime navigation that relies on sound as much as on sight. When you hear a chorus, imagine each frog building a mental map of voices around it, using tiny differences in arrival time to choose where to go. Worldwide, many frog populations are threatened by habitat loss and climate stress. Frogs depend on a delicate set of conditions, and those conditions are being squeezed from many sides. Wetlands are drained or filled. Forest edges are cut back. Streams are diverted. Even small changes can matter because many frogs rely on specific breeding sites and specific moisture levels. Climate stress adds another layer. Heat waves can dry shallow pools before young finish developing, and unusual rainfall can shift breeding seasons out of sync with food and safety. In some places, storms become more extreme, while in others, drought stretches longer than the frogs are built to endure. The hard part is that frogs cannot simply pack up and move easily. especially when suitable habitat is scattered into small, isolated patches. When you hear a chorus in a healthy pond, it can sound endless. Yet in many regions, those voices have become rarer. The loss is not only sad, it changes ecosystems because frogs play roles that other animals do not replace. A deadly fungus has caused major declines, showing how disease can reshape nature. There is a disease story in the frog world that moved like a shadow across continents. A fungal infection can attack frog skin, and skin is not optional for frogs. It is part of how they balance water and salts, and part of how they exchange gases. When that system is disrupted, the body can fail in ways that look sudden from the outside. In many places, populations collapsed quickly, even in habitats that seemed intact. It was a stark lesson. Conservation is not only about protecting land. It is also about invisible threats that travel through trade, movement, and contact between species. The fungus also showed how interconnected nature is. A single pathogen can ripple outward, changing food webs and reducing biodiversity in a region. When a frog vanishes, it can feel like one small animal lost. This disease revealed that millions of small losses can add up to a transformed world, fast. Some frogs survive fungus better due to helpful skin bacteria. On frog skin, there is a tiny community you cannot see, and it can change the fate of an animal. Some frogs carry beneficial bacteria that help defend against harmful microbes, including disease-causing fungi. These bacteria can compete with invaders, and in some cases they can produce compounds that make it harder for the pathogen to take hold. This means survival is not only about the frog itself. It can also depend on the microscopic neighbors living on its skin. Two frogs of the same species might face the same threat and have different outcomes, partly because their protective microbes differ. For scientists, this opened a hopeful direction. If healthy microbial communities can support resilience, then protecting habitats that maintain those microbes becomes even more important. It also reframes what a frog is. A frog is not a single organism acting alone. It is a partnership, a living surface where biology and microbiology meet, and where survival can hinge on invisible allies. Road traffic can fragment frog habitats, blocking migrations to breeding ponds. Many frogs are faithful travelers. They may spend much of the year in one area, then move toward a breeding pond when conditions are right. The route can be short, yet it can cross roads that did not exist when the frog's instincts formed. A road can turn a simple journey into a gauntlet. Cars arrive fast, and frogs move slowly on dry pavement. Even when individuals survive, traffic can split populations into smaller groups that rarely mix, which reduces genetic diversity over time. The problem is not only the road surface, it is the fragmentation. A safe pond on one side may become unreachable from shelter on the other. In some regions, wildlife tunnels and seasonal road closures help, and the difference can be dramatic. When people guide frogs across during migration nights, it can look like a small act. In reality, it is protecting an ancient movement pattern that still drives frog life today. Night lighting can disrupt frog calling, changing who mates with whom. Frogs evolved their nighttime routines under darkness shaped by moon and stars. Artificial light can rewrite that environment. Bright streetlights near wetlands can make frogs more visible to predators, and that can reduce calling because calling draws attention. Light can also interfere with timing. Some species are most active at certain light levels, and an illuminated shoreline can shift when they emerge, how long they call, and where they choose to gather. When calling patterns change, mate choice can change too. A male that would have been heard in a dark corner might go silent under a lamp. Another may dominate simply because he calls from a shadowed spot. Over time, this can reshape breeding success in subtle ways, even when the water itself looks healthy. It is a reminder that habitat is not only plants and ponds. It is also the sky above them, and the rhythms of night that animals use as a signal to begin. Pesticides can affect tadpole growth, even at surprisingly low doses. A tadpole's body is under construction, and construction is sensitive to what is in the water. In agricultural and suburban areas, pesticides can wash into ditches, ponds, and wetlands after rain. Even small concentrations can matter, because tadpoles live immersed in the water every day. These chemicals can alter growth rates, stress the immune system, or affect development in ways that make young less likely to survive to the next stage. The challenge is that the water may look clear and normal, while the chemistry has changed. A healthy-looking pond can still carry an invisible burden. This is part of why frogs are often used in environmental monitoring. The effects can show up in the young first, and the consequences can echo through an entire breeding season. When fewer young reach adulthood, a chorus can fade in the years that follow. The story begins quietly, with a runoff event that seems small. The impact can become loud later, when the pond is missing voices. Wetland restoration often brings frogs back, sometimes within a single season. When a wetland is repaired, the response can feel like a return of music. If water is restored, native plants recover, and shallow edges form again, frogs may arrive quickly, sometimes in the very first breeding season after restoration begins. They may come from nearby ditches, streams, and hidden pockets of habitat, drawn by moisture and suitable places to lay eggs. The first calls can be an emotional moment for people working on the land, because it is a sign that the system is becoming functional again. Frogs respond fast because they are tuned to water presence and shelter, and because their life cycles can take advantage of newly available pools. Restoration also helps more than frogs. Insects rebound. Birds follow. The wetland becomes a living network again, not just a patch of soggy ground. This is one of the hopeful stories in conservation. Damage can take years. Yet with the right changes, recovery can begin quickly, and frogs are often among the first to announce it. Captive breeding has saved some species, but reintroductions remain challenging. When wild populations collapse, conservationists sometimes turn to captive breeding as a lifeboat. In controlled environments, endangered frogs can be protected from habitat loss, pollution, and disease exposure, giving the species time to persist. This approach has prevented extinctions and created populations that can someday return to the wild. Yet returning is the hard part. A released frog needs suitable habitat, safe water, and enough food. And it must also face the same threats that caused decline in the first place. Reintroduction also requires careful planning, so the animals have the right genetic diversity and the right behaviors for survival. Some species depend on very specific breeding sites, and without those, release efforts can fail. Captive breeding is not a simple fix. It is a bridge. It can keep a species alive while humans work to repair the world that species needs. The goal is always the same: a self-sustaining population that no longer needs a lifeboat. Citizen scientists can record frog calls, helping map populations over time. You do not need a laboratory to help protect frogs. Because many species announce themselves with calls, people can contribute by recording what they hear and when they hear it. A short audio clip can become a data point that shows a species is present in a location, even if the animal stays hidden. Over seasons and years, these records can reveal shifts in range, changes in timing, and places where populations are growing or fading. This matters because professional surveys cannot be everywhere at once, especially in remote wetlands or small local ponds. Community recordings can fill the gaps, creating maps that are richer and more current. It also changes the relationship between people and nature. Instead of passing a pond without noticing, a listener begins to recognize patterns, rhythms, and differences between voices. The night becomes readable. When many people contribute, the result is a kind of shared listening project, turning scattered moments of attention into a clearer picture of frog life across a region. Some frogs use warning colors to advertise danger, a strategy called aposmotism. Bright skin can be more than beauty. In some frogs, bold colors act like a public sign that says, "Stay back." Predators learn fast, because one bad experience can connect that color pattern with nausea, irritation, or a burning mouth. Over time, the message spreads through the local food web, not by conversation, but by avoidance. That visibility can seem risky, yet it can reduce attacks overall, which makes survival easier than constant hiding. The colors can also work at close range, when a curious animal is deciding whether to bite. In some habitats, these frogs move openly in daylight, because their warning is part of their defense. The result is a strange kind of confidence in a small animal. Instead of blending in, it chooses to be seen, and it makes the world remember why that is a bad idea. Other frogs rely on camouflage patterns that break up their outline. Many frogs survive by becoming hard to notice, even when they are right in front of you. Their patterns can scatter light and shadow across the body, which makes the outline harder for a predator to lock onto. Some look like mottled bark. Others resemble pebbles, mud, or speckled leaf litter. This works best when the frog holds still, because movement gives the game away. Camouflage is not only color. It is posture and placement. A frog may press close to a branch, flatten against a rock, or angle its body to match nearby lines. In that moment, the frog becomes part of the background, and the predator's eyes slide past. This strategy is a quiet kind of power, because it lets a frog stay close to food and water without drawing attention. The most impressive camouflage often feels like a magic trick, until you remember it is biology and patience working together. Certain frogs mimic dead leaves so closely they fool predators and people. In forests, where the ground is carpeted with fallen leaves, some frogs take disguise to an extreme. Their bodies can be shaped and patterned to resemble a curled leaf, complete with uneven edges and vein-like lines. The effect is strongest when the frog stays still among real leaves, because the brain expects to see leaf shapes there. A predator scanning for eyes and limbs may miss it entirely. Even people can walk past without noticing, until the frog suddenly moves and breaks the spell. This mimicry is not only about hiding. It can also help the frog rest during daylight, when many hunters rely on sight. The disguise turns an exposed forest floor into a safe bedroom. It is a reminder that evolution can sculpt an animal to match a common object, and it can do it so well that your own eyes, which you trust, can be gently deceived. Some frogs have eye spots that startle attackers and redirect bites. The predator often aims for the head, because one well-placed bite can end the chase. Some frogs counter that with a clever illusion. They display eye spots on the back or sides, patterns that can look like large, staring eyes when the frog is threatened. The sudden appearance can startle an attacker for a fraction of a second, and that pause can be enough for escape. Even when the predator commits, the false eyes can redirect the bite toward a less vital part of the body. Instead of striking the head, the predator may grab a flank, a leg, or a fold of skin. That still hurts, yet it can be survivable. This tactic turns appearance into a shield. It is not about being invisible. It is about being confusing at the worst possible moment. In the split second when life depends on reaction time, a painted illusion can change the outcome. A few frogs puff up to look larger, buying a moment to escape. When danger arrives, some frogs inflate their bodies like living balloons. Air is taken in, and the frog expands until it looks rounder and harder to handle. The goal is not to fight. The goal is to become inconvenient. A predator that planned to swallow a small meal may hesitate when the meal suddenly seems too large, too awkward, or too likely to get stuck. Inflation can also make the frog harder to grip because a swollen body slips away more easily. In some cases, the posture changes too. The frog lifts itself, stiffens, and angles the body to appear even bigger. It is a bluff, yet it is a useful one, because hesitation is time. Time is a hop. Time is a dive. Time is a chance to reach cover. This strategy shows how defense can be about buying seconds, not winning a battle. Some frogs secrete sticky mucus that makes them hard to grab. A frog's skin can produce more than moisture. In some species, the secretion becomes thick and sticky, turning the body into something that feels like it belongs to the swamp itself. For a predator, that stickiness can gum up a mouth or glue fingers, which makes holding on difficult and unpleasant. The frog may slip free while the attacker is distracted by the sensation. The mucus can also reduce friction against surfaces, which helps the frog slide into crevices or under vegetation. This defense is especially effective because it changes the rules of contact. A predator expects skin and muscle. It gets a sticky mess that complicates the grip and slows the chase. For humans who handle frogs for research, this can be memorable because the residue can cling and stretch like soft glue. It is a chemical escape tool produced on demand, and it turns a close encounter into a problem the predator did not plan for. Certain frogs have bony skull spines that can help in defense. Not all frog defenses are soft. In some species, the skull can include ridges or spines that make the head tougher and more dangerous to bite. A predator that clamps down may meet hard bone in places where it expected a smooth meal. This can discourage repeat attacks, and it can increase the chance of being dropped. The skull shape can also help the frog wedge itself into narrow shelters. A hard, angular head can brace against rock or wood, making it harder for something to pull the frog out. That is a different kind of defense, one based on structure rather than chemistry. It suggests a life spent in tight hiding places where a strong head is both tool and shield. These frogs remind us that amphibians are not always delicate. Some carry armor in the most important place, right behind the eyes, where a single bite could otherwise be fatal. A few species play dead, becoming still when handled. Sometimes the best move is to do nothing. A few frogs respond to threat by going limp and motionless, as if life has already left the body. Predators often rely on movement to confirm prey, and a sudden stillness can break that pattern. An attacker may loosen its grip, lose interest, or shift attention to something that looks more alive. This strategy can also reduce injury during handling, because struggling can trigger harder bites and more shaking. Playing dead is risky because it depends on a predator choosing to release. Yet in the right context, it can be surprisingly effective. Once the pressure eases, the frog can spring back into action and vanish into cover. The contrast is part of the trick. One moment, it is a lifeless object. The next, it is gone. It is a reminder that in nature, escape is not always about speed. Sometimes it is about convincing an enemy that the chase is already over. Some frogs can leap into water and vanish with barely a splash. A frog at the water's edge often has one plan ready, and it is fast. When danger appears, it can launch into the water with a clean arc. then disappear before the surface settles. Many frogs enter at an angle that reduces noise and spray, which matters because sound and ripples can guide a predator. Once submerged, the frog can tuck into weeds, press against mud, or hold still beside sticks and stones that break up its shape. The water becomes a second landscape, full of hiding places that are invisible from above. The escape is not only the leap, it is the disappearance. A predator may reach the bank a heartbeat later and find nothing but calm water and a few drifting rings. That vanishing act is one reason frogs thrive at edges. The boundary between land and water is dangerous, yet it offers a trapdoor. For a frog with good timing, the pond is not just home. It is refuge. The coqui frog helped define Puerto Rico's soundscape and identity. On warm evenings in Puerto Rico, a small frog can become part of the island's heartbeat. The coqui's call is clear and unmistakable, and it carries through gardens, hillsides, and neighborhoods after sunset. People grow up with that sound, so it becomes tied to memory, place, and home in a way that is hard to explain until you have heard it night after night. The call also marks territory and attracts mates, so the sound is doing real biological work while it shapes human culture. When coquis are absent, the night can feel strangely empty, as if a familiar instrument has dropped out of the song. When they are present, they turn ordinary darkness into a living chorus. It is a reminder that wildlife is not only seen, it is heard, and it can become part of identity. Ancient cultures linked frogs with rain and fertility across many continents. Long before modern biology, people noticed patterns that were impossible to ignore. Frogs often appear when rains arrive, and their calls can surge during wet seasons. That timing made them natural symbols for water, renewal, and the return of life to dry ground. In many cultures, frogs show up in stories, art, and ritual objects because they seem to announce the moment when fields would green again and rivers would rise. The link also makes sense in a practical way. Where there is water, there are frogs. Where frogs thrive, wetlands and ponds are usually active and productive. That connection between frogs and abundance became part of how people explained the world and how they hoped to influence it. What is striking is how often the same idea appears in distant places with no contact. Different languages, different landscapes, and the same observation. When rain returns, frogs return. A symbol was born from a shared experience of seasons. Frogs have flown in space as research animals for gravity and balance studies. A frog's body is built around movement, so it can reveal what changes when gravity changes. In space, researchers have used frogs to study balance, orientation, and how the nervous system responds when up and down lose their usual meaning. Frogs have inner ear structures that help detect motion and position, and those signals guide swimming, jumping, and writing reflexes. In microgravity, familiar cues vanish, and the brain must interpret a new sensory world. Observing how frogs adjust can help scientists understand basic vertebrate physiology, and it can also inform how humans adapt during long missions. There is something poetic about it. An animal shaped by ponds and forest edges has helped explore the emptiness above Earth. It is a reminder that space research is not only about rockets and machines. It is also about living bodies and how they stay coordinated when a fundamental force is changed. Frog embryos help scientists understand how vertebrate bodies form in early development. A frog embryo is like a living diagram because changes happen quickly and clearly. For decades, scientists have studied frog development to learn how a single fertilized cell becomes a body with a spine, organs, and a patterned layout. Early stages reveal how cells divide, move, and take on different roles, and those patterns can be observed without the complexity that comes with larger animals. This work has helped researchers understand concepts like body axes, tissue layers, and how signals guide cells toward becoming muscle, nerve, or skin. It has also supported discoveries about how mistakes early on can lead to major changes later. What makes this powerful is that frogs are vertebrates, which means many of the same basic developmental rules apply across a wide range of animals, including humans. Studying an embryo the size of a small bead has helped reveal the hidden choreography that builds a backbone and a beating heart. Certain frog toxins inspired medical research into pain control and heart function. In the natural world, a chemical that protects a frog can also become a clue for medicine. Some frog skin compounds have attracted research interest because they interact with nerves, muscles, or signaling pathways in ways that could inform drug design. Scientists do not take a toxin and turn it into a pill overnight. They study how it works, what it targets, and what parts of the molecule might be useful when modified and carefully dosed. This process has helped explore new ideas in pain control and in how hearts regulate rhythm and strength. The bigger story is that evolution has been running chemistry experiments for millions of years. A frog that survives predators by producing a powerful compound is also revealing a biological mechanism that humans may not have discovered otherwise. It is a reminder that biodiversity is not only beautiful, it is informative. A small amphibian can carry a chemical lesson that reaches into laboratories and hospitals. The African clawed frog aided early pregnancy testing, shaping medical history. Before modern rapid tests, pregnancy detection was slower and less reliable. In the mid-20th century, the African clawed frog became part of an unusual medical method. When certain hormones are present, these frogs can respond in ways that helped indicate pregnancy, and the results could arrive faster than many other options of the time. The practice spread widely in some regions, and it shaped how clinics approached early confirmation for years. This history also reveals how science and society intertwine. An amphibian from southern Africa became linked to human healthcare across oceans, and that link changed demand, transport, and research focus. It is a surprising chapter where biology, medicine, and global movement meet. It also reminds us that scientific tools evolve. What once required living animals can now be done with small chemical strips. Yet the frog's role remains a vivid example of how humans have relied on other species to answer intimate questions about our own bodies. Some frogs can live surprisingly long, especially in cool, stable habitats. A frog can seem delicate, yet some species can persist for many years when conditions are steady. Cooler climates and stable environments can slow metabolism and reduce stress, which can support longer lifespans. In the wild, survival is shaped by predators, disease, and harsh seasons, so living a long time is an achievement earned through many narrow escapes. In captivity, where food and safety are consistent, some frogs have been known to live for decades. Longevity changes how you think about a frog's life story. It is not always a brief summer creature. A long-lived frog can witness repeated seasons of drought and flood, and it can return to breed many times across its life. That matters for populations because older adults can stabilize numbers when a few breeding seasons go badly. When you hear frogs calling, you may be listening to individuals with years of history behind them, not just a single season of life. Many frogs return to their birth ponds, guided by smell and memory. A breeding pond is not always chosen at random. Many frogs show a kind of hometown loyalty, returning to the same general area where they began life. The journey can cross forest floor, fields, and rocky edges, and it may happen under cover of night or after rain. Smell plays an important role, because water and soil carry chemical signatures that can act like landmarks. The landscape becomes a map made of scents, moisture gradients, and familiar pathways. Returning to a known site can increase success because the frog is coming back to a place that worked before. Yet it also creates vulnerability. If the pond is drained or polluted, the instinct to return can lead frogs to a place that no longer supports them. That is why protecting breeding wetlands matters so much. These are not interchangeable puddles. For many frogs, they are destinations, remembered and sought out across seasons like a promise kept. A frog's skin can taste, detecting chemicals in water and on prey. For a frog, the world is full of chemical information, and skin helps read it. Many frogs have sensory cells in the skin that can detect dissolved substances, which makes sense for an animal that lives in constant contact with moisture. This ability can help a frog assess water quality, locate suitable habitat, and respond to the presence of other animals nearby. It can also influence feeding, because chemicals on prey or in the water can signal what is edible, what is risky, and what is worth pursuing. The result is a kind of distributed sensing. Instead of relying only on eyes and ears, the frog can gather information through its surface, almost like the environment is touching back. This makes frogs especially sensitive to changes in water chemistry, and it also makes their behavior more understandable. A frog may avoid a pool that looks perfect to us because the skin is detecting something we cannot. Its world is richer than our senses suggest. Some frogs hibernate underwater by absorbing oxygen directly through their skin. In winter, some frogs spend months at the bottom of ponds or slow streams, and they do it without coming up for air the way mammals must. Cold water holds more dissolved oxygen than warm water, and a frog's slow winter metabolism needs less fuel. With skin that can exchange gases, the frog can absorb enough oxygen from the surrounding water to stay alive, while it remains mostly still. It must choose the right place. The water needs oxygen, and the bottom cannot be completely stagnant. The frog also needs to avoid freezing solid in the wrong conditions, so depth and flow matter. This survival method turns a pond into a winter shelter, not just a summer home. When spring arrives, the frog rises back into the active world, and the same body that endured underwater stillness can soon be calling again at the surface. It is a seasonal magic trick powered by physiology and cold water chemistry. The Suriname toad carries eggs in skin pockets until tiny toads emerge. This is one of the strangest forms of parenting in the animal world. After mating, the eggs are pressed onto the mother's back, and her skin swells around them. Each egg ends up in its own small pocket, like a living nursery stitched into the body. Inside those pockets, the young develop in safety, protected from hungry fish, drying air, and shifting water levels. Weeks pass, and the back looks patterned, almost like a honeycomb of small chambers. Then the moment arrives. Fully formed young toads emerge from the pockets, ready to face the world without a free-swimming tadpole stage. It sounds impossible until you see it described, and then it becomes unforgettable. This is not a nest built in a pond. It is a nest carried everywhere, turning one parent into both shelter and delivery system. Darwin's frog fathers can raise young inside a vocal sac. In this species, fatherhood becomes a form of careful carrying. After the eggs hatch, the male gathers the tiny young and takes them into a space connected to his voice. The same area used for calling can become a safe chamber where the developing offspring stay moist and protected. While they grow, the father must balance survival with caregiving, and he cannot treat the days the way a carefree frog might. Predators still exist. Hunger still exists. Yet the young remain tucked away, sheltered from dangers that would pick them off in open water. When development reaches the right point, the father releases them into the outside world. The image is striking. A voice, becomes a cradle. A call becomes a doorway. It is a reminder that frog reproduction is not only about laying eggs and leaving. In some lineages, it is about carrying the next generation in the most surprising place. The Goliath frog can build stone nests, moving rocks with its body. Along certain forest rivers, a massive frog may do something that feels almost like construction work. A Goliath frog can shift stones with its body and legs, clearing and arranging a space that helps create a safer place for eggs and young. The goal is not architecture for beauty. It is a practical nursery, often in shallow water, where flow and depth can be controlled by the arrangement of rocks. Moving stones is demanding for any animal, and it reveals just how powerful these frogs can be. It also shows planning. The frog is not only reacting, it is shaping the environment so the next stage of life has better odds. In a river that changes with rain, a stable pocket can matter. When you imagine a frog as a builder, you start seeing amphibians differently. Some do more than survive a habitat. They modify it. The purple frog lives underground and has a narrow snout for termites. This frog looks like it stepped out of a different era. It spends most of its life underground, hidden in soil where humidity is steadier and temperatures swing less. Its body is built for that darkness. The head is shaped with a narrow snout that helps it push through earth and feed on termites, which are abundant below the surface. Above ground, it can seem awkward and slow. Below ground, it is in its element. It may surface only briefly during heavy seasonal rains to breed, then disappear again into the hidden world of tunnels and roots. This lifestyle means many people could live near one and never know it exists. When it does appear, it is a reminder that biodiversity is not always loud or visible. Some of the most unusual frogs are not perched on leaves. They are buried beneath them, living a secret life in the soil. The tomato frog can ooze sticky secretions that irritate a predator's mouth. A bright red frog can look like an easy target until the first bite teaches a lesson. The tomato frog can release a thick secretion when threatened, and the effect is more than slipperiness. The substance can be irritating to a predator's mouth and eyes, which can make the attacker recoil, spit, or wipe its face in discomfort. That reaction creates the opening the frog needs. In a moment of confusion, the frog can scramble into cover or simply be dropped and left alone. The defense is also memorable, which helps the frog in the long run. Predators that learn once may avoid that shape and color again. It is a chemical boundary, delivered instantly through skin. The frog does not need sharp teeth or fast claws. It needs a strong message and a way to make the message unpleasant to ignore. In the forest, that kind of deterrent can be worth more than speed. The waxy monkey tree frog spreads skin oils to reduce water loss. Some tree frogs live in places where dry air can arrive quickly, even when the landscape is green. The waxy monkey tree frog has a clever routine for that problem. It can secrete lipids from its skin and spread them across its body using its limbs, almost like applying a protective coating. That oily layer helps slow water loss, which can allow the frog to rest through drier periods without dehydrating as fast. The behavior looks deliberate, like grooming, and it turns the frog's own chemistry into a survival tool. This matters because tree life exposes animals to wind and sun, and moisture can evaporate quickly high above the ground. By managing its skin surface, the frog buys time and stability. It can choose when to move and when to stay still, rather than being forced into constant search for dampness. It is a quiet example of how amphibians can solve a hard problem with simple, repeatable behavior. The hairy frog can break toe bones to form temporary claws. This defense sounds like a myth, yet it is rooted in anatomy. In the hairy frog, certain toe bones can be pushed through the skin to create sharp points that function like claws. The frog does not grow true claws like a cat. It creates a temporary weapon by using its own skeletal structure in an extreme way. The idea is grim and impressive. When threatened, the frog can turn its feet into something that can scratch and deter an attacker, especially in close quarters. Later, the body can heal, and the bones return to their usual position. This is not a strategy for everyday life. It is a last resort. That makes it even more startling because it shows what some animals are willing to do when escape is not possible. In a single moment, a soft amphibian can become unexpectedly dangerous, using bone as a tool when the situation demands it. Some frogs glide between trees using webbed feet and stretched skin. In dense forest canopies, falling can be fatal, so some frogs have evolved a way to travel through air with more control. Gliding frogs can launch from a branch and spread wide webbed feet, sometimes with extra skin along limbs, creating a broader surface that catches air. They do not flap like birds. They steer and slow, turning a drop into a controlled glide that can carry them to another trunk or leaf cluster. This ability can help them escape predators, reach food, and move without climbing down into the dangerous world below. It also changes how the forest is used. The canopy becomes a connected map of routes, not isolated perches. For humans, the sight can be astonishing. A frog becomes airborne, and it does not simply fall. It sails. The skill is a reminder that flight is not only wings and feathers. Sometimes it is webbing, posture, and a body plan that makes the most of the air between trees. A few frogs can survive in brackish water, near coastal mangroves. Most frogs are closely tied to fresh water because salt can disrupt water balance in the body. Yet a few species manage life where rivers meet the sea, in habitats like mangroves and coastal marsh edges where the water can be brackish. Surviving there requires careful control of salts and hydration, and it requires behavior that avoids the harshest conditions. These frogs may choose microhabitats where rainwater dilutes salt, or they may time activity around tides and freshwater pulses. Living in brackish zones can offer advantages because some predators and competitors are less common there, and the habitat can be rich with insects. It also places frogs in one of the most dynamic environments on Earth, where salinity, temperature, and water level shift constantly. When you think of a frog, you may picture a woodland pond. These coastal survivors remind you that amphibian life can push into salty borderlands, finding narrow pathways where physiology and habitat line up. Frogs evolved many times into similar shapes, showing nature repeats winning designs. Across the world, frogs that are not closely related can end up looking surprisingly alike. A stream specialist in one region may resemble a stream specialist far away because fast water rewards similar solutions. A burrower may resemble another burrower on a different continent because digging favors certain shapes and strong limbs. This is convergent evolution, and it is one of the most fascinating patterns in biology. When the same challenges appear again and again, evolution often returns to similar answers, as if nature is testing designs and keeping what works. Frogs make this easy to see because they have diversified into so many lifestyles. Tree climbers, ground hiders, water racers, and desert waiters all exist within the group, and similar roles can produce similar bodies. The lesson is humbling. Evolution is creative, yet it is also practical. When a design solves a problem well, it can appear more than once, independently, like a melody discovered by different musicians. Several frogs can climb smooth surfaces using toe pad adhesion and posture. Watching a climbing frog can feel like watching gravity lose an argument. It can scale a slick leaf, creep along a vertical trunk, and sometimes cling to glass after rain. The secret is not strength alone. The toe pads make close contact with the surface, and a thin layer of moisture helps create strong grip through friction and adhesion. The frog then uses posture like a careful rock climber. It keeps its center of mass close, spreads limbs to share load, and places each foot with deliberate angles that maximize contact. On rough bark, it can use texture. On smooth surfaces, it relies on precision. This ability opens up a three-dimensional world where food and safety can be higher than most predators can reach. It also turns ordinary surfaces into roads. A wall is not a barrier. It is a path, climbed one quiet step at a time. As we come to the end of our journey, it helps to notice just how much ground we've covered together. We moved from quiet ponds to rushing streams, from forest floors to treetops, and even into places hidden underground. We followed lives that begin as drifting eggs, transform into swimmers, and later step onto land with lungs, legs, and voices. We listened to calls that fill warm nights, watched bodies adapt to cold, drought, height, and darkness, and glimpsed the many ways frogs solve the simple challenge of staying alive. Along the way, these small animals revealed big ideas. They showed how water and land stay connected, how balance can be delicate, and how survival often depends on timing, patience, and flexibility. Some stories were loud and dramatic. Others were quiet, unfolding slowly beneath leaves, skin, or still water. Together, they form a world that is ancient, resilient, and endlessly inventive. Now, there is nothing more you need to hold on to. Let the images soften. Let the sounds fade into something distant and steady, like a pond settling after a ripple. Allow your breathing to slow, your shoulders to soften, and your thoughts to drift without needing direction. Everything you've heard can rest where it is. If you enjoyed this winding path through the world of frogs, you're always welcome to explore another video that may be waiting for you, if sleep hasn't quite arrived yet. And if these nighttime journeys bring you comfort, a like, a subscription, or a quiet comment can help others discover their way here too. But for now, the day can release you. The night can take over. Sleep well, and good night.